Assalamualaikum warahmatullahi wabarakatuh. My name is MAWADDAH binti MAHMUD. My matric number is AF22004. This is our video presentation for Mechanics of Material project. For introduction part, in today's world, there are growing demands of lightweight and high performance material in various fields like construction, sport, aerospace, and automobiles. Composite material known as impressive strength to weight ratio and durability as emerging as a cutting-edge choice. The design, fabricant, and testicle of composite material project aim is to explore all aspects of creating this material from the initial idea to practical application. This study will dive into understanding how composite materials are designed, made, and tested, emphasizing their ability to outperform traditional materials in strength, flexibility, and resilience by combining different materials like fiber and matrices. The project will also focus on environment aspect, effectiveness, and sustainability, promoting the use of recycled and bio-based material in composite fabrication. By encasing composite material technology, the project aims to encourage their widespread adoption across the various industries, leading to more efficient and eco-friendly solutions. In our project titled Design, Fabrication and Testing of Composite Material, we have choose PVC, that's a polyvinyl chloride, model board as our material for several important reasons. Firstly, PVC model board offer the excellent dimensional stability, allowing us to create the precise composite structure. In low thermal expansion and contraction characteristics ensure the finished component maintain their shape under the various temperature conditions. Second, high strength and regularity of PVC model board enable to detail design with the composing stability, providing structural support during the production. The material inherent strength contribute to the resilience and durability of the composite construction. Additionally, PVC model board is lightweight, making easy to handle and assemble. It's low weight and also help to reduce the overall weight of the composite material, enhancing to the performance and authenticity in various applications. Moreover, PVC model board is readily available, affordable, and also easy to maintainable, making a great choice and for quick prototype and small-scale production. Overall, using the PVC model board in our project ensure the accuracy, dependability, and efficiency in fabrication and testing composite material. And this is our PVC model board. So for the design and fabrication detail, cost of our construction is glue. It costs only 6 ringgit. Fabrication time is 1 week, and member plate size leg is 200 mm and the wide is 20 mm.
Assalamu alaikum warahmatullahi wabarakatuh. My name is AHMED FARAH. My matric number is BF22009. So the object of our project is creating and designing a composite plate with more than 8 plies or layers using unrecycled resource, testing the composite plate to ascertain its modulus strength, and the validity will be evaluated in relation to expense, duration, structural robustness, and distinctive attributes. Concept of composite plate fabricated. A lightweight core material frequently formed of foam is sandwiched between two stiff outer layers in the notion of foam board. Foam boards are adaptable and frequently used in a variety of industries for tasks like construction, science, and arts and crafts. Typically, foam boards have the following elements: foam core, the foam core, which forms the board middle layer, is what makes it so light. Polyurethane and polystyrene foam, both of which have good insulting qualities, are typically used in its construction. The board's foam core keeps it lightweight while still giving it stiffness and stability. Outer layers, outer layers. Two outer layers often comprised of paper, plastic, or lightweight composite materials are placed between a foam core. These outer layers offer structural stability, safeguard the foam core from harm, and provide a surface from attaching objects or breathing on.
My name is VEHGINESH and I'm going to talk about the tensile test. Okay, so a tensile test, known as a tension test, is a mechanical test used to determine the mechanical properties of a material, particularly its behavior under tensile forces, and is one of the most common and fundamental tests performed on materials, especially metals and alloys. The purpose of a tensile test is to measure how a material responds to applied forces and to obtain important mechanical properties such as ultimate tensile strength, yield strength, elongation, and modulus of elasticity. And these properties provide valuable information about the material's strength, ductility, stiffness, and overall performance. And the first step in conducting a tensile test involves preparing a standardized sample from the material under investigation. And the sample is typically machined into a specific shape such as cylindrical, rectangular. The design gauge length and cross-sectional area. Once the sample is prepared, it is securely mounted within a testing machine, usually a universal testing machine, and it holds the specimen without spillage throughout the test. And next is the application of gradually increasing load to the specimen, and the testing machine applies an axial force, steadily increasing the load until the specimen fractures or until the design data points are obtained. Okay, so during the test, the testing machine continuously records an applied load and simultaneously measures the resulting deformation experienced by the specimen, and the measurement enables the calculation of stress, which represents the applied force per unit area, strain, which represents the deformation relative to the original length of the specimen. So by plotting the stress value against the corresponding strain values, a stress-strain curve is constructed. This curve illustrates the material's response to the applied tensile force and typically exhibit distinct regions indicating elastic deformation, plastic deformation, or ultimate fracture. Thank you.
Assalamu alaikum. My name is Mustafa ABDURRAHMAN Barkindo. My part of the project is the strength analysis calculation. First is the stress strain graph for sample 1, 2, and 3. As you can see, this is for the sample 1 and this is for the sample 2. The next is the figure 3 showing the stress strain graph for sample 3. The figure above shows the data that we obtained from a tensile test of 3 sets of composite plates that we manufactured. We used PVC model board as composite material. The 2 sets successfully tested and one failed because it was not strong in the gluing process. Thus, based on the figure 3, that is the graph we obtained. As we can see that the graph was not holding, showing the ultimate strength and also breaking point because of the process error. Meanwhile, for sample 1 and 2, according to the graph, we can see that it has shown the ultimate strength and also breaking point when the tensile test was conducted. From the graph, we can obtain stress and strain value for the composite material. Thus, the value of young modulus can obtain from gradient of graph of strength strain, which is stress per strain. Apart from that, the value ultimate strength is also obtained from the graph. Next is the calculation for the young modulus, which is equals to stress over strain for the sample 1 and sample 2. These are the calculation: 2.517 minus 1.367 divided by 0.298 minus 0.277, which gives us 54.01 GPa. The same process is repeated for the sample 2 and we obtained 48.15 GPa. The average value of young modulus is the combination of sample 1 plus sample 2 then divided by 2 to obtain the average, which is equals to 51.08 GPa.
Discussion.
Based on tensile tests, the highest young modulus indicates for group 7, which use polystyrene as a composite material. The value of young modulus show higher because the young modulus is depending on type of material. The hardness of drawing paper less compared to other materials. When the hardness is less, the strength also less, and it hard to withstand the applied load without failure or plastic deformation. We use foam board as composite material. The young modulus that our group obtained is 54.01 gigapascal. We have tested 3 sets of composite plate and 2 sets are superly tested, and 1 set failed because of the gluing process is not good and the plate is not strong. Conclusion. The project also underscored the importance of sustainability and environmental impact consideration in composite material development, exploring the use of recycled or bio-based material, as well as evaluating the long-term durability and recyclability of composite, has paved the way for more eco-friendly approaches in future endeavors. The project on designing, fabricating, and testing composite materials has shed light on the immense potential and practicality of these advanced materials. By pushing the boundaries of engineering and material science, we have unlocked new possibilities for lightweight, durable, and high-performance structures, fostering progress and innovation across various industries.